This is an AP Chem tutorial that covers pH and pOH in strong and weak acids and bases. pH comes from the French phrase puissance de hydrogen, meaning the power of hydrogen. This is the equation for pH and pOH. pH and pOH of a solution add up to 14, which can be very useful when finding the pH of a base. Finding the pH and pOH of a strong acid and base is rather simple because, following the definition of a strong acid and base, they dissociate completely, meaning the concentration of the original solution is equal to the concentration of hydrogen or hydronium ions in the solution. This means you simply have to plug in the concentration into the formula, and voila, you have the pH or pOH. For this example, I am using question 3 from lecture 30. I simply plug the 0.55 molar concentration into the formula for pH and solve. Finding the pH or pOH of a weak acid or base requires the use of an ice table to find the hydronium or H+ ion concentrations necessary to find the pH or pOH. First, you want to use an ice table to find the concentration of the H+ ion. And so you use the initial concentrations. Obviously the products don't have any initial concentration. So then you subtract X amount of concentration from the reactant and add it to the products. So you have 5.8 minus X, and you have X for both of the products. You then use that information to set up an ice table. So you have Ka equaling the H+ concentration on top, as well as the C7H5O2 minus concentration on top. Those are the products. And then on bottom you have the reactant, which is just the acid. So HC7H5O2, that concentration goes on bottom. So then you replace the concentrations with their variables found in the ice table. And so the two products on top are just X, and underneath you have 0.58 minus X. And you assume that X is negligible and beneath 5% of the overall concentration, so you can just get rid of it, and then you're left with Ka equaling X squared over 0.58. So then you're solving for X, and so you get the variables on one side, X squared, and that equals Ka times 0.58, and Ka is 6.4 times 10 to the negative fifth times 0.58, and that leaves X squared equaling 3.712 times 10 to the negative fifth, and then you square root both sides, and you're left with X equaling 6.09 times 10 to the negative third.